Welcome back to the top-down shooter tutorial in Godot using 3D. This is a really long title. I need to think of something better for it. It changes every time I do an intro. But in this video, we are going to be creating some particle effects. So I've actually gone ahead and already created these, and I'm not really going to create them again. So I'm just going to kind of show you the settings that I did. I will create one from scratch, but I have two particle effects here. And I'll show you the process of creating one of them, and you can just play around with them. So this one here does that, and I've got a little spark which just does that there. So to create one of these, I'm going to make a new scene, and I'm going to go other node, and I'm looking for CPU particles. Now 3D GPU based particles are going to be better, but I know that most of my students are currently working in GLES 2 just because of some bugs that we have on the fairly low-end computers that we have at school. So CPU particles will work on that. I'm not sure if there's actually a difference between GPU particles. It looks like there is a fair difference between the two. So I'm just going to be working with CPU particles for now. So what we want to do is first of all turn off emitting. I'll actually turn it on because we'll be able to see some things, and then later we're going to kind of make it a one-shot emission. We're going to play around first with the emission shape. So the emission shape here, not the emission shape, the drawing. So the drawing here, we're going to set a mesh, and I'm just going to use a new cube mesh. Now once that mesh is in there, you can click on this, and I'm going to scale this down to 0.2, 0.2, 0.2. And you can see what it's doing there. I'm going to set the material, new spatial material. I'll click on that one and change the albedo to red. And then I'll just go back and click on CPU particles over here. Now I can close that drawing section now, and the ones that I played with here, and you could spend a lot of time playing with this and doing a whole lot of things with it. I'm going to keep this fairly simple. I'm going to turn this velocity up to 1 and the velocity random to 1. The direction I'm going to change from X to 0 and then Y to maybe 3. Like that. Down here we've got linear acceleration, angular velocity. I didn't really worry about any of these things here. What I'm looking for is explosion. And it's under time. So once we've done that, we can go to time. Now I turned up my particle amount to about 50, and you can kind of see what it's doing here, and I turned up the explosiveness. You will need to, and that gives you that. Then I played around with initial velocity. Whoa. And probably want somewhere around 5 to 10 for that. You can also set the angular velocity. I don't know really what that does there. There's a few things here that I played around with that didn't seem to have much of an effect, but the initial velocity definitely did. So I'm going to put that on 7, and I get that kind of effect. Now I'm going to play around. What's the speed scale do? That just makes it go faster. I'll leave that at 1. The explosiveness, that is going to make all the particles, if it's at 0, they'll kind of come out one at a time. If it's at 1, all the particles are going to come out all at once, which is generally what we want. It's just kind of something explodes. You can say how long it stays there for. But we're just going to have it for 1 second. And then I'm going to turn emitting off. So once I've done that, I'll save this as whatever I want to call it. I called one blood spray and the other one spark. I actually spelled that wrong. And the other one was a spark. I used a slightly smaller mesh for that, that was longer on the y-axis, but it didn't really need to be. So I'm actually going to change that to 0.05. And there we go. Now to actually get this working, there's a few places that we need to add it. So I'm going to go into the scripts. And once again, I've already done this in here. So I'm just going to show you where I did it. So in each of the enemy zombies, right at the top, I added a onReady var, in this case blood, equals preload, and then the scene that I want to instantiate. so that that particle scene that I want to instantiate. Notice that's the only thing in the scene. You can probably instantiate an entire particle system using code. It's going to be a lot longer in code, so I may as well just make a scene that's got all the settings ready to go. So we've got that in there. Now in the bit where we actually hit the zombie and we go if health is less than or equal to 0, we queue free. We're going to play the animation. No, we're not going to do that. That's what you would do if you had a death animation. I don't. We are going to declare that there is an instance of our particle effect that's going to be created. We're going to set the global transform of the particle effect to be the global transform of wherever this zombie was. And we're going to get the parent, add child, and add this variable. In this case, this is not a very good variable name. However, it's being used one-off and only in this location. So it's actually fine. B represents an instance of this variable. Once this is done, it forgets about it. It's not like we have to remember it again. Any programmer reading this could see, okay, B, done. All right, good. And then lastly, we set B dot is, set emitting to true. Now what that will do is I should be able to go into here and I can shoot. You can see nothing shows up yet. If I go through here and shoot these guys, we get the particle effects. There we go. There is, from what I can tell, there is a way to instantiate those things as rigid bodies, which would be really fun, but I can't seem to figure it out at the moment. So if I do, I'll update the video with how to do that, and then you'll get the little particles staying on the ground. But I'll figure that out if it's possible. It may not be possible with CPU particles. That may be why I haven't found any particular option here. Now the spark is a little bit different. For the spark, we need to go into the script for the player, and it might be called movement.gd for you, but the script for the player, I've added this at the top here. So variable spark equals preload. You notice sometimes I do on ready, sometimes I don't. It doesn't really matter in this case, but I'll put it there. And that should probably go at the top, kind of order those things nice and neat. So I've got my spark scene loaded, ready to go. And then in the bit where we check the hit, I'm going to add, well, if we're not hitting a zombie, either zombie, then what we're going to do is just create the spark at the position that the raycast is getting a collision point from. So it looks like this. S, like B, equals spark.instance. So we instantiate a copy of that spark, and then we set its global transform equals $, and I know I just skipped a bit then if you're reading ahead, dot get collision point. Now this get collision point is a vector 3. Global transform, if you're not sure what the transform is, if I just click on something here, I'll click on the player. The transform is this, which consists of the translation, that's its position in 3D space, its rotation, and its scale. Okay, so that is the transform. It's all of those different things together. Because the collision point doesn't include rotation and scale, it's just a point in space, we can't actually just say global transform equals that, because this is not a global transform. This is just a vector 3. It's just a 3-dimensional point. So what we can do is say dot origin. Okay, and that's going to set the origin of the spark to be the get collision point. Then we'll set it to emitting, set emitting true, and lastly add it. So get parent dot add child s. Now what this means is we can run our program, and anywhere we shoot on the wall, we get these cool little spark effects. So that looks pretty neat, and it actually kind of goes there before the tracer fire gets there, which is what you want. Well, it's probably not realistic, but it doesn't matter. I guess the tracer fire is going to be as fast as the bullet. It's not like the bullet's faster than the speed of light, so it should be fine. But this is all good. This works. We could do it where the tracifier hits it as well. We could do it then. That would time it better. But it doesn't matter. We've got some particle effects. We've got loads of little things on the ground here. We've got some other funny particle effects here as well. And you could make those as ridiculous as you want. And if I can figure out how to make them as rigid bodies, I will do that as well.